everyone, so today we will discuss about spectrophotometry. Okay, so my name is Chong Ching Hong.
And my name is Muhammad Shafi.
My name is Muhammad Husni bin Mustafa.
Hello, my name is Retuli Brady.
Hello, my name is Muhammad Shahi Najmi.
Hello, my name is Revati Warden.
Hi, my name is Nur Izzi binti Zainuddin.
Hello, my name is Alia binti Amer.
So now I will talk about the brief introduction of spectrophotometry. So spectrophotometry is a method to measure how much a chemical substance absorbs the light by measuring the intensity of light as a beam of light passes through the sample solutions. So the basic principle is that each compound absorbs and transmits light over a certain range of wavelength. So this measurement can also be used to measure the amount of a known chemical substance. And then in spectrophotometry is one of the most useful methods of quantitative analysis in various fields such as chemistry, physics, biochemistry, material and chemical engineering, and clinical applications. Okay, that's all from me. So now I will pass the rest of the introduction to Revati.
Hello. Now I will briefly explain about spectrophotometry introduction. This equipment is really every chemical compound absorbs, transmits, or reflects light over a certain range of wavelength. Spectrophotometry is a measurement of how much a chemical substance absorbs or transmits. Spectrophotometry is widely used for quantitative analysis in various areas. As we know, it's used in chemistry, physics, biology, biochemistry, material and chemical engineering, clinical applications, industrial application, and much more. Any application that deals with chemical, industrial, or substances can use this technique. In biochemistry, for example, it is used to determine enzyme catalase activity. In clinical application, it is used to examine blood or tissues for clinical diagnosis. This equipment also an instrument that measures the amount of photons is known as the intensity of light absorbed after it passes through sample solution. With this spectrophotometer, the amount of a known chemical substance can also be determined by measuring the intensity of light detected. That's all from me. Thank you.
So I believe that every one of us will love the spectrophotometer. Yeah. But I think we have to know about the structure of spectrophotometer. Yeah. So do any one of you know about the structure of spectrophotometer?
I can explain to you guys about it.
Oh,
Great. Okay, now I will explain about the components of spectrophotometer. Spectrophotometer actually has 4 components, which are light source, spectroscope, sample cell, and also detector. Okay. For the light source, it actually has 2 kinds of lens, which are tungsten and deuterium. For tungsten, its measurement is in the visible and near infrared range. Its range are between 340 to 1100 nanometer. For deuterium, its measurement in the ultraviolet range and its wavelength range are between 185 to 360 nanometer. Next, I will proceed to the spectroscope. Spectroscope plays a role in selecting a monochromatic light from a visible light source. It includes filter type, prism type, and grating type. Okay, next for the sample cell. Sample cell is a container that contains a sample that are usually called cell. There are 2 types of sample cell, which are glass cell and quartz cell. Okay, lastly, for the detector, detector plays a role in changing the light transmitted from a sample into an electric signal. Examples of detector are optical semiconductor and also photomultiplier. I will pass to next.
Okay, I will add some from what Izwin has said. Okay, a spectrophotometer is an instrument that measures the amount of photon, the intensity of light absorbed after it passed through the sample solution. With the spectrophotometer, the amount of a known chemical substance, which is concentration, can also be determined by measuring the intensity of light detected. Depending on the range or wavelength of light source, it can be classified into two different types. One is UV visible spectrophotometer, which is this one. It uses light over the ultraviolet range, which is between 100 to 85 and to 400 nanometer, and visible range from 400 to 700 nanometer of electromagnetic radiation spectrum. Okay, this next is IR spectrophotometer, which is infrared spectrophotometer. It uses light over the infrared range, which is from 700 until 15,000 nanometer of spectromagnetic radiation spectrum. In visible spectrophotometry, the absorption or the transmission of a certain substance can be determined by the observed color. For instance, a solution example that absorbs light over all visible range, in example, transmit none of visible wavelength, it appears black in theory. Okay. And then on the other hand, if all visible wavelengths are transmitted, it absorbs nothing. So the solution sample appear white. Okay, that's all from us.
So this is the structure of a spectrophotometer.
Yeah. Now only we know there's two types of spectrophotometer. The first one is
UV visible spectrophotometer.
and the second is
IR spectrophotometer.
Okay, you guys, do you know what the absorption spectrophotometer?
No, I don't know.
Oh, it's good. Because I will explain to you.
Yeah.
Actually, the absorption spectrum primarily is determined by the atomic and molecular composition of material. Radiation is more likely to be absorbed at a frequency that match the energy difference between two quantum mechanical states of molecules. The absorption that occurs due to transition between two states is referred to as absorption line, and a spectrum is typically composed of many lines. The frequency where absorption lines occur, as well as their relative intensity, depend on electronic and molecular structure of the sample. Frequency will also depend on interaction between molecule in sample, the crystal structure in solid, and also several environmental factors such as temperature, pressure, and also electromagnetic field. The line will also have width and shape that are determined by the spectral density or the density of the state of the system. That's all for me. I will pass to Fred for more detail about the absorption spectrum.
So Fred, can we learn a little bit more about the spectrophotometry?
Oh yeah, sure. So, so what has been said by Zulu's data star, I would like to add some minor stuffs on it. Alright, so when atoms and molecules absorbs these radiated energies, or to put it simply, we call it just light, okay, they will absorb they call it the term photon, alright? It's not a term for a radiated energy, right? So what happens there is that they will undergo a change, okay? For the atoms, okay? So atoms and their state is defined by the electron arrangement in their atomic orbitals. So what happens there, when the electrons in one of the orbitals, they absorb one photon, all right, which is closely equals to the difference between two orbitals. Okay, they absorb this photon, and then they get really excited, and they are able to move to another level of the orbital. All right, so for the molecular state, okay, it is defined by their modes, which is vibrational and also rotational. So what happens there, these modes are quantized and also similar to the atomic orbitals, they may also become excited when they absorb a single photon, right? Or vice versa, becomes dull, and they release a photon. So for both the atomic and molecular cases, they don't really stay the way they are, as in being really energetic after absorbing photons. After some random amount of time, they will revert back to their original state. For the atomic part, what happens there is that the electron that absorbed the photon will release it, right, and then revert goes back to its original orbital. But for the molecular context here, the vibrational or rotational mode, it decays, but also emits a photon, right? So when this decay process occurs, the photon produced does not necessarily is released the same way it was being absorbed. So for on most parts, commonly the released photon is released at an angle of 45 degrees. So for an example, if there's a gas that lies between a light source and an observer, the observer will experience a sight where he or she observes the gaps of the spectrum. All right. So because of what I've just explained just now, the light that passes through a substance or molecule, all right. So it's been absorbed and then released. So we can see the separation of the spectrum there, in which it will be prolonged because the photons that are being released are continuously being absorbed and then released back at random angles. So it may take a while for it to really pass through for that particular gas. So these gaps, which I have mentioned there, will appear as black lines in an image of the spectrum. So yeah, that's pretty much it for the absorption of spectrum in a molecule. Yeah.
Interesting.
Interesting, yeah.
Yeah.
Thank you to Fred for the briefing. Okay, now it's my turn to talk about the function of spectrophotometry in bioassays. Basically, a spectrophotometer is a photometer that can measure the intensity of light as a function of its wavelength. Spectrophotometer is one of the most widely used analytical procedures in biochemistry. Okay, let's move on to the first spectrophotometer function. Spectrophotometer used to estimate the level of an analyte in solution and is ideal for sample routing determination of small quantities of materials. Linear range of absorption and spectral bandwidth measurement are the important features of spectrophotometers. Secondly, spectrophotometers can be used to identify the compound by determining the absorption of the maximum wavelength. And then, spectrophotometers also can be used for color determination, which is the color wavelength. The wavelength of that color is within the spectral range. If one is working in the range of 380 to 700 nanometers, the spectrophotometer can also use for color determination, which is the wavelength that remain within the wavelength is the color that is the same. Last but not least, spectrophotometers also can be used in molecular biology laboratories. Example, microbiology and molecule laboratories use spectrophotometers to measure the growth of bacteria culture. So, in conclusion, the spectrophotometer quantitatively compares the amount of light passing through the reference and test sample. For reflectance, it compares the amount of light reflecting from the test and reference sample solution. Thank you.
Oh, so that's how bioassay works by using the technology of spectrophotometry. Okay, now I would like to go to my part, which is about the technological breakthrough using the technology of spectrophotometry. Okay, one of the spectrophotometry technology that have been used, which are in the spot categories. For the spot categories, the technology that have been used are implemented in by detecting the hemoglobin and oxygen saturation inside the blood. By using this method, they could precisely measure the amount of oxygen, like I said before, and oxygen inside the blood to measure either their regime or their routine is efficient to them. Thus, they could create another regime if their previous regime is not suitable for them. Alright, how do they do that? They just directly take it from their skin, which is it's not painful at all, and then it's in an expensive. Okay. Cut balik ke? Alright. Kita cakap apa? Besides, this technology is very inexpensive, so it could use regularly for the other categories, which is the medical. I want to share to you guys that for surgical patients, they do need to monitor their blood oxygen level, which is very important to maintaining their healthy brain function. Usually before this, they will take the blood, which is an invasive method, which will cause some cut, which is gonna cause more recovery period. So for this technology, we know that it's an invasive method, which means that they will does not increase the recovery period of the patient. That is one of the wonder of spectrophotometry. Alright, so for the second example, I'm also under the medical categories, which is for the neonatal care. Alright, baby is such a fragile being that by using a rough method or invasive method, they could cause more injury or more increase the recovery period. So by using this new technology, we could also doesn't affect the recovery period at all. So in other words, it's gonna help a lot, especially for those unfortunate child. Alright, I think that's all from me. You guys have any other opinion?
That is interesting. You give a good explanation. So that's all for the discussions of today. We have learned a lot.
Yes, exactly.
So for conclusion, I want to conclude that spectrophotometry is a very, very good technique in our daily life. Okay, so that's all for the discussion. Thank you very much.